Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have 14 years of work experience in the fields of artificial intelligence, software development, and robotics. We are creating email spam detection project using machine learning. If you have missed the previous session, you can view it on YouTube. So I will show you the simplest code, what vector means and why you need it. So to convert text into numerical format, so you cannot feed the text data to machine learning model. I repeat, you cannot feed this data to machine learning model that we just created CSV. It requires specific format. So what is specific format? One of the format is term frequency inverse document frequency. So TF-IDF. So what it will do is, if you convert your text to numerical format in this particular format, it helps the model to understand the importance of each word. So whatever you pass, it will understand the importance of each word using this format. So whenever you pass the data to machine learning model, you pass it in this numerical format, particular format. So vectorizing the text data refers to the process of converting raw text like emails, reviews, any unstructured text into numerical features that a machine learning model can understand and work with. Since machine learning algorithms cannot directly interpret text data, we need to transform it into a format that they can process. And TF-IDF is one of the most commonly used techniques for this purpose. I have mentioned everything in the article. You can go step by step and read it in the simplest manner that I can do. I have created this article. So how you can do it? This is the library sklearn, and you can use this particular library, or say I will show you what this is. So if I control plus click here, this is the class. So this is the class. So class, you can pass these arguments like this, and finally what it will do is convert the raw data to this particular TF-IDF format. So let's see the next step. So this step we converted the raw text data to TF-IDF. Why? Because this is what machine learning models read. It does not read raw text data. Next thing, so we got the data and converted it to machine learning that machine can understand, not an issue now. So next thing is to split the data into training and test set. So what this means is, we have huge amount of data, and what we need to do is segregate it or distribute it in two categories. What is training, and second is test set. What training set will do is, it will help you to train a machine learning model. What training set will do is help you train the machine learning model. What test set will do is help you to gather the result, final results. So for final result, test set, and for training, training. So you don't have to get into too much complexity. This is the simplest way you can do it. sklearn will give you this train test split. Just write it this way and you are good to go. That's it. You just have to write this and you are good to go. You can read more about it if you want. I have mentioned everything here, even the minute details if you want. So you can read about it. I will skip it for now because of the simplicity, and then tell you the next important thing: training the naive Bayes model. What it means is, let's train the naive Bayes model, which is often used for text classification due to its simplicity and effectiveness. So the naive Bayes model is a family of probabilistic machine learning algorithms based on Bayes theorem. So what it is particularly effective for classification tasks such as spam detection. So this theorem is being used here because they are saying that it is effective for classification tasks such as spam detection, sentiment analysis, text classification. So this theorem is being used. You can read in detail what this is about if you want. This is purely mathematical. If you want to read it, you can read it, but for our program it is not that important. So naive Bayes is called naive because it assumes that the features, example words in an email, are independent of each other, which is often not the case. So what it is saying that, so I am having this line for example, and it is saying that congratulations and you have are not connected with each other. So this is not the real use case, but they are saying that if you use naive Bayes model, naive Bayes theorem or this model, then it will work fine. You will not find any problem. So this is what they are claiming. You can recheck it on the internet if you want. So there are three types, but I will tell you the simplest or what we are using here is thing. I want to tell you that this program output will look something like this, and before moving on to next thing, I will just tell you how to read this classification report and what it means. So this is very important. This means how your model is performing and how you train the model. So let's see these things. So if you remember, I told you that I gave 1 for spam and 0 for ham. So this is what it means, 0 for ham. So this line tells the report for ham, good emails. 1 will tell, this line will tell about the spam. So this is ham, this is spam. How to read these things I will tell you again. I have mentioned everything in the article. Let's see. Okay, so first one is precision. What it means: out of all emails predicted as not spam, 75% were actually not spam. This is what it means, precision. Out of all emails predicted as not spam, 75% were actually not spam. Let's see in our case what we are getting, 97. So out of 97, so our precision is 97% here. Next thing is recall. What recall means is the model correctly identified 100% of the not spam emails. So this is what recall is all about. Let's see. Yeah, we have 100% here recall value. Next thing is harmonic mean of precision and recall for not spam emails. If you want to know more about what harmonic mean is, so you already have learned about mean. If you want, you can search it on Google if you want. So this is the mean of precision and recall for not spam emails. Last one is support. What support means is there are 3 not spam emails in the test set. So here we have support 3 and here we have support 482. So we will say that there are 482 not spam emails in the test set. This is what we will say. So this is how you read the classification report. I have mentioned everything here. You can see for class 1. So let's see, for class 1 precision is 0.98. How you will read it? Out of all emails predicted as spam, 100% were actually spam. This is what this is how you read this classification report, and this is very important because anyone in the future will ask you, can you tell me the accuracy of the model, can you tell me what give me the classification report of the model, and using this report you can determine if this model is usable in the real environment. And yeah, one more thing, I have shown you the data sets. These are small data sets. I will show you the size of these data sets. This is really small, 13 MB for ham and for spam 4.32 MB. So these are really small data sets. I will not recommend using these type of data sets for a commercial purpose. So this is just like you can say demo, or what you can do is download the large data sets and put it here. What it will do is it will create a model with more accuracy and more with more data. You can detect more spam emails. So if you take example of Google, they will be using huge data because they have data for billions or millions of users, millions and billions of users have their data on Google, and they are training their models on that size. So this is the reason their models are working so smoothly, because they have large data available. And for training that kind of data, huge data, you need machines capable of doing or computing that kind of data. So I took this small data sets, because on my computer I don't have this kind of hardware, so I can run small data sets only. So this is how you create or say use data sets and create a CSV file and see the classification report. I will continue with this creating this project and tell you how step by step it will work. So what is remaining in this code is just this. All the main things I told you in this session are already available in the articles. You can read it step by step, and you can just change this text. You can change this text with any text you want, and you can test this model. One thing you will notice that you have seen that there are separate model files available that will be stored here, but in our case we are not seeing any model here, although I have trained the model. So in next session I will tell you how to save the model and reuse it. So I have already created the article, this save a trained model for later use, that I will show you in next session. So it is nothing complex. You just have to store the pkl, I think, file, pkl file. So yeah, pkl file, just that's it. So you can send this model to your friend and they can use the program without the training dataset. So you can run without dataset the program if you save the model on your computer. So this is what you see on if you go to Hugging Face and other platforms, this is what you see, the model files. So there are two types you can use, so job lib and pickle, to store your model files. I will not go into detail because tomorrow I will be showing you how you can do this. In next session I will continue making this project. See you in next session. Have a nice day.